Hey guys, it's Stereo Police. I'm back with yet another video. This one's a little different. Wasn't planning on making this one either, but that's how these things go. I just tinkering around and decided to make videos on different things that I'm doing. And this one, well, this is about another new toy. I recently purchased my favorite toy, I think, so far, out of all of them. And that's my Keithley 2015 THD multimeter. This thing is outstanding. As soon as I learn all the features, or what the features I need to know, I'll make a video about that one day. But I've been using it as a voltmeter and total harmonic distortion analyzer, and I just love it. And so as I was doing that, I used to measure THD with my old Heath kit harmonic distortion analyzer, which works. Nothing wrong with it, but it only provides a certain level of accuracy. I don't really trust it to be that accurate, and it's not precise. It doesn't give you an nth degree precision. And what I don't like about it is repeatability. I mean, I can keep the situation the same over and over again, and take multiple THD measurements. Take some time to do too, and I never get the same THD twice. It's fairly close, sometimes not close, so I never really trusted it, but it's all I could afford at the time. But anyway, so during the process of taking THD measurements, I realized that the signal sources I was using as input, namely the one I've been using for years, which is this guy right here. It's probably dark now. This Instek function generator, which is starting to get a little fussy with me, with the frequency counter not working and that sort of thing. But anyway, I realized that those things produce waveforms that, as a matter of their output, have high THD, relatively speaking. In other words, in the range of, 0.1 to 0.4%. And that's not, I mean, while that might be good enough for just putting signals through equipment and tracing signals and that sort of thing, that's fine. But when measuring THD, you need something as an input source that's more accurate. And so I used to, whenever I did THD, I used this, which is this is a BK Precision audio oscillator. It's about $80, $80-$90. It's an audio oscillator, audio frequencies. I love it. It's great. It's cheap, and it works, and it never fails. It's just fantastic, and it produces THDs on the order of 0.02. Sometimes lower, depending on where you have the amplitude and depending on the frequency. That's really good enough to measure THD for me. However, you can't sweep frequencies with this. There are individually selectable frequencies. And that little amplitude knob is kind of a pain in the butt sometimes. And so anyway, long story short, I wanted to upgrade to an audio oscillator that is low THD, that's easy to use, big dials. I'm getting older now. I need big dials and big numbers. Big dials and very accurate, and that's why I have high hopes for this thing right here, which just came in the mail today. Got it from Amazon, where I get a lot of my stuff, mostly because I get you might be able to get better prices elsewhere, but I love their customer service, and I'm part of Amazon Prime, and I get it in 2 days. When I order something on the web, I want to see it in 2 days, man. So that's what you get. And the return policy is fantastic. So anyway, what we have here that I'm about to unbox is my Instek GAG-810 audio generator. And this is what it came with. It came with a certificate of traceable calibration. It was calibrated. Gives you the calibration procedure and the equipment they use and that sort of thing, and that's fine. I trust it. I'm going to verify it, but I trust it. Now, here's what else it came with. Came with some. Let me unbox. I'll tell you what. I'm going to go ahead and unwrap this, and we'll take a look at it. Okay, we're all unboxed. So I've not done a thing other than unbox right now. I'm going to learn how to use it in a minute. It should be pretty straightforward, right? You think? So, certificate of calibration, power cord, some leads. They are banana to alligator, and product packing list, and declaration of conformity. Goodwill Industries. This is the something from the guys who did the calibration, and a nice manual. Everything was well boxed. Everything is high. These appear to be high quality. Good IEC power cord, and a nice manual. I mean, look at this. Got a little window in the front. Nice cardstock. Not that it matters, but I'm so used to, these days buying Chinese crap and getting the most awful manual you could ever want, both in terms of content as well as quality. This is nice. I mean, it's always nice to unbox something and everything is nice, high quality. This is I'll get into this in a minute. It has a metal case, plastic front, nice big knob, has a good feel to it, a good consistent feel. The buttons. Everything has a good feel to it. Everything, the potentiometer here, nice, decent quality binding post, decent for the price. What was the price of this thing? I don't even know. I think it was 180 bucks. I think. It's pretty close to it, if not. And so far, well worth every damn penny to me. So far. On the rear, we have an external sink. So again, this is metal case, nice handle on the top, appreciate that. Plastic front, plastic knobs, plastic dial indicator. So I'm going to put this thing through its paces in a few minutes. Let's take a quick look at the manual here. Audio signal letter, nice big letters, hope it stays that way. Oh, nice and big, look at that. Features. Low sine wave distortion. Excellent. That's why I'm buying this. Frequency ranges. I don't need the megahertz stuff. I like staying in the audio range. I don't tinker with tuners much. I might one day. Distortion factor. I don't know what a distortion factor is. Oh, that's the GAG-810. Okay, so the GAG-810, 500 hertz, 20 kilohertz, 0.1%. But I didn't get the 809. I got the 810. See that? You go from 9 to 10, and you get an order of magnitude less distortion. How about that? See that? Numbers mean something, right? Go from 9 to 10. Like that movie, well, what's that, Spinal Tap, where you go to 11. I want the model GAG-811. The dial would go higher, I guess. I don't know. So there's the distortion for the GAG-810, which is 0.02. That's what I'm looking for, man. That's why I'm here. And I'm going to measure it, too. Nice big letters. Look at that. Nice. I'm so used to crappy as hell manuals. Circuit description, Weinbridge oscillator, nice. This is like the old school manuals you used to get with stuff, what audio equipment and other things, where they actually told you how the thing worked. And sweet. I like the manual a lot. I don't know why I'm talking about it. People are probably watching this going, talk about the manual. Let's get down to business here, which I will in just a minute. Just quickly going through this. Some cautions. I never read cautions. Does anyone read cautions? That cautions page, like you get something, there's like 3 pages of cautions. You're all in a hurry to get through it to get to the good stuff. Okay. Maybe I better read the cautions. I don't know. Anyway, so what I'm going to do next is let's go ahead and get this thing hooked up. Let's look at the signal on the scope first. Test every single switch and button on there. And then measure the THD. I'd like to measure the THD not just without a load or with a high input load. I'd like to measure. I wonder if I can. I bet you I can switch loads on this thing. I bet you I could. I haven't learned how to use this totally yet, but I might want to. I'd like to measure. I'll go ahead and do it with a high input impedance load first, and then I'm going to do it loaded with like a 47K or maybe even output this thing directly to the input of an amplifier and measure it from there loaded, because the characteristics of things when they're under load are different. When there's a an almost infinite load, when I say infinite load, I should say an infinite input impedance to the next circuit, or mega ohms, that sort of thing. Very little current is flowing. I want some current to flow out of that thing to load the amplifiers a little bit to make sure that that THD stays the same. You all know what I mean. So, okay. Hit pause here, and I'm going to get a test situation set up with my scope and THD meter, and let's see if this thing works. And I'll tell you what, if it works as advertised, I love it. You can sweep frequencies, easy to hit the buttons. It doesn't have a frequency counter on there, but my scope. Oh, by the way, I'm getting a new scope too. That's a different video. That's on the way. I got really upset with this thing, which is, what is it, an Omron? It's a cheap Chinese piece of crap. And my old scope was that one, which still works, but I needed some digital functions on there. I needed some mathematical functions. And I didn't have the money years ago, so I bought that, but I am now really pissed off at it. Once I get pissed off at a piece of equipment, I hold grudges. And so I bought a Tektronix, and that's on the way. I'll probably be getting that tomorrow. And I'll make it not one of their least expensive models, mind you. I don't have that kind of scratch, but I'm looking forward to that. Finally, it'll be the best scope I've ever had in my life, probably. I mean, I'm looking forward to getting that. But anyway, we'll use this scope today, probably for the last time, before I turn it into a paperweight or an anchor. And to test this guy and do some THD, I'll be back in a flash. All right, I'm back. Got a little test set up here. I'm not using a load. The only load is going to be the load of the oscilloscope probe. I guess in parallel with the load of the THD analyzer. And so, real simple to use so far. I love it. So I wanted to start out with a frequency of 1 kilohertz, and here's your range selections. So I pushed times 100, and the dial ranges from 10 to 100. So 10 times 100 is 1K. So I'm going to start out at 1K, and there's the nice waveform there. I have it adjusted to 4.93 volts right now. And there's a frequency 1.004K. So what the dial says lines up so far nicely. And the waveform, well, it better look nice, right? And the THD right now, 0.005. It's bouncing around a little bit, but 0.005 or so. And that's even better than my my oscillator there. Happy with that. Very happy with that. That's very, very low. So let's see how the dial lines up as I go a little higher. So we're at 1K, 2K, 3, 7, 8, 9. Let's go to 10K. And frequency is 9.8 9.9K, so once again the dial lines up very nicely. Not that you would use a frequency counter, of course, to get precise, but the dial lines up very well. There's the waveform, and distortion hasn't changed. THD is still low. Again, I'm at 5 volts. Now, in terms of this button here, of course, is for whether you want a square wave or a sine wave. I have little use for square waves for what I do. Although they could be used to test for slew rate of an amplifier. There's an attenuator and an amplitude dial, and I have the attenuator on 0 now, so we can see the full range of voltages that'll be output. So we'll take it down to 0, and of course we have no frequency, and the voltage is you can't read the frequency. Voltage 79 millivolts. Let's go over here to measure. Now I'm gonna leave that alone. I'll trust the oscilloscope's pretty good with respect to voltage. So we'll increase it, and we'll see how high it can go. I'm turn the dial all the way up. See what our maximum RMS is. Okay, dial is all the way up, and there's our wave, and we have 11.31 volts. We still have the same amount of THD, just about. That didn't change. Let's see what this accurate voltage reading gives us. 11.365 volts, and that's pretty much what the scope says. So we can get up past 11 volts. I typically, for audio use, I have little need for that, but that's nice to know. And of course the attenuator will step it. I'm going to rotate this once to the left, and that just gets you down when you're working in the millivolt range. It gives you when you're working in the millivolt range, it gives you basically a finer adjustment of the voltage, of course. When you're on 0 attenuation, you get a very coarse adjustment. So this is basically like a coarse fine, essentially is what it is, a coarse fine adjustment for amplitude. So let me go back up to around 5 volts. Get my THD set up again. I'm measuring 6 harmonics. No filtering. Okay. So we're at 5 volts, and we are. Let's start out 10 times 1. Okay, so what's that going to be? That's okay, there we go. That's going to be 10 hertz, and that's what we have here. We have 10.31 hertz. And I'm getting an underflow on the THD. Maybe the THD might not go down to 10 hertz. Let me just try that again. Getting an underflow of data on there. Don't know why. I haven't used this much, but let's take her up to 20. Okay, so somewhere between 10 and 20. This THD probably doesn't go below 20. But anyway, we're at 20 hertz, and there it is, 20 hertz. We're still at around 5 volts, and 6 harmonics. So getting down to the low end, we're looking at a little more harmonic distortion, somewhere about 0.1. Not as good as I had hoped. But let's look at the opposite end of the spectrum, and let's push the 1K. So now we're at 10 times 1K, we're at 10K. And why is my triggering goofy? Trigger menu. Triggering on channel 1. Okay. Measure. I don't know why I'm getting some instability there. Hang on just a second. There we go. Okay, so we're at 9.9K, and our THD is way down again to where it belongs. So somewhere the THD begins to rise at lower levels. And let's go ahead and go to 20K. 20K, and there's 19.87. THD very down low, very stable. Let's go back down to our ×1 again and go up to 100 hertz. See, the scope is not, it's taking its sweet time. What have I done? Should be at ×1. It's 100 hertz. And my scope doesn't want to measure. See, I'm having this. The scope has been upsetting me lately. I'm pushing auto set. And hang on a sec. Okay, I just had to tinker with the scope a little bit. Okay, so we're set at 100 hertz. There we are. We're at 11 volts. I want to go back down to about 5, somewhere in the mid-range of its capabilities. I really don't need 5 volts either as an input source, but anyway. So we're looking good there, and our THD is starting to rise. Okay, so I'm going to back this down from 100 hertz to 20. Okay, and let's see what happens to the THD. Okay, I'm at 40 hertz right now. 0.06. We go down to 25. Starting to bounce around in the 0.09s, and then down at 20 hertz. That's when we get to close to 0.1. And at some point, as I'm going down, there's underflow. So the THD meter doesn't want to work with me down below 20 hertz. I don't care. That's fine. That's the frequency that it will deal with. But it's still very good. Let me go down up to 30 hertz again, just out of curiosity, get a nice stable. Okay, so 0.007. All right, so this easy to work with. I love it. Good quality. A bargain in my opinion for the price. And I made the video just to show you the new toy, but also to show you that, you know, this thing is go to 100 hertz again, down to 0.04. So that's really all I need. I wonder what my THD is for this guy at 20 hertz. I wonder if it's any better. I can tell you that the THD for most of the frequency range, what was it again at a kilohertz? You go to 1K again. Should have written that number down. 0.005 or 6, right? Okay, so let's and it was 0.0. It was almost 0.1 when I got down near 20. So let's see what this is again, just to compare. This is pretty good. Let me write that down. 1K point 0.005, and then down to 20 hertz, about 0.1. Okay. Okay. So I'll hit pause here and hook this guy up to it, and then we'll hook one of the other signal generators up, and just to get a comparison. I'll be right back. Okay, so for the GAG-810, 20 hertz, it went to 0.1%, but almost everywhere else it was 0.005%, 1K and 20K. So now let's look at the BK audio generator, the 3001, and I'm set at 1K, and there's our screen, and we're at 1K. The output is 1.2 volts. This doesn't generate more than about 2 volts, and we're looking at 0.02. All right, 0.02%. Let's go to 20. Let's go to 20 hertz. Okay, now we're at 20 hertz. We're about 1.2 volts. There's our 19.96 hertz, and this does pretty good. 0.09. Okay, it's about 0.1. See that? So I'm going to call it even. 0.1%, and let's go to 20K. Can I get, where's my 20K? Hold on a second. Okay, so I had to change the range and then figure out which one of these was going to be. It's 100 times 200. So there's our 20K, and we're at 0.01, really 0.02 if I round up. So 0.022%. Okay, so far the GAG-810 beats it across most of the audio spectrum. Now let's, as a last fun thing to do, let's pull an audio. There we go. Let's pull this guy that I used to use. Okay, it's a signal generator. Sorry, a function generator. There's a difference. Function generator. This artificially synthesizes waveforms as opposed to being an audio oscillator. And let's hook that up and see what kind of THD we're getting. Okay, so we got the Instek looking for the model number. Oh, that's GFG. Not that it matters. I doubt you can get this anymore except on eBay maybe. 8020H. Okay, so it might be hard to see because of the glare, but we are at We're at 1K. We're on a sine wave. There we are. It says 1K lower right. 2.69 volts out. That's fine. I'll keep it about there. And 0.7%. 0.73 at 1K. 0.73%. See the big difference? And that's probably normal for these synthesized, or for these function generators. I mean, maybe there's really, maybe you can get one that's really super expensive, but you probably have to go a lot higher than the $180 you pay for that to get low THD on one of these. Okay, let's try 20K. Hold on. Here we are. 23, 22, lower right. 19.8, close enough for me. Let's hit auto set. Okay. 0.3, 0.27. 0.27%. Got better, got better with frequency. Let's try 20 hertz, huh? There we are, 19.4579. There's 20 hertz. Okay, we're at 20.03 hertz, and we're at 2.69 volts, and we're at 0.789. Really 0.8. 0.8%. So there we go. So I'm glad. This, and by the way, this has a bigger voltage range, 0 through 11 volts. This one only goes up to about 0 through about 2 volts. And what does this one go? What does this one do right here? I'm going to crank it up as high as it goes. Ah! hold on. 7.9 volts, 8 volts, 0 through 8 volts. RMS for all. So far this is going to be my most flexible audio generator, lowest distortion. I'm going to use it exclusively. I'm going to see if I can hook this up as a frequency counter and just use it as a counter so I can get a digital readout of the frequency. I think I can do that on here. I'll work on that later. But of course the scope, these modern scopes all give you the frequency anyway, but I like the big bright letters on top of the bench or whatever, so I can just quickly look up and rotate the dial and see it from a distance without getting close to the scope. So there you have it. Oh, by the way, when I cranked the voltage up, THD went up to 0.9. So we're at 20 hertz, so that makes a big difference. Let me lower the voltage down to about 2 volts. So we're down. Yeah, okay. We were at 0.8, so it's roughly the same, 0.7. Okay. So there you have it. This guy's the winner. The reason I made this video is not to say, hey, gee, I got a new toy I want to show you, and I got another new toy. I figured if this turned out to be good, I would commend it as a bargain. And that I can safely. I can't tell you about the longevity of it. Obviously, I just got it. I can't tell you about the durability of it. But these things are all over the place. A lot of people have them. It's just kind of a staple on many workbenches. These or something similar. So it's going to be damn good. I guarantee you the circuitry inside that thing is robust. It's probably, you know, the basic design of this probably goes back to the 40s, you know, or 50s, or before that. It's real simple. Nothing fancy in there. And that's why it's so damn good. So I can recommend the GAG-810. Don't get the 809. That's an order of magnitude higher in distortion. It's the 810 that is the low distortion unit. I doubt there's that much difference in price too. So, okay, well, this is another impromptu video on got my new toy. I want to recommend this audio generator. Probably a lot of you watching already have one or one similar to it. But this is the best one I've ever had. I've been relying on this for years. The reason why I wanted to upgrade is when I got this guy here and now I can measure accurate THD, I need a low distortion input source. That's why I bought it. And I'm glad I have it. Ciao. Enjoy. Have a nice weekend. It's Friday here.